Step into the future and explore the incredible plans for building an underground civilization on Mars. From high-tech excavation equipment to cutting-edge habitation technology, witness the breathtaking engineering feats that will pave the way for human settlers to thrive on the Red Planet. Get ready to go deep underground and discover the secrets to creating a self-sustaining society in one of the most inhospitable environments in our solar system. Join us on an epic journey to Mars and witness the incredible vision of building an underground civilization that could shape the future of humanity. Building an underground city. Building an underground civilization on Mars is a massive undertaking, but it's also essential for the long-term survival of human settlers on the Red Planet. The first step in creating an underground civilization would be to locate suitable sites with favorable geological features such as stable rock formations and access to water. Once a suitable location is identified, the construction process would begin with excavation and drilling. Specialized equipment and technology would be required to carve out living spaces, storage areas, and other necessary facilities, such as laboratories, manufacturing plants, and power stations. To protect against radiation and extreme temperatures, the living spaces would need to be covered with layers of insulating materials such as soil, rock, and ice. Solar-powered lighting and air filtration systems would be essential to create a habitable environment. Food production would also be critical to sustaining life underground. Hydroponic and aeroponic systems could be used to grow crops and produce fresh food. Water would be a valuable resource and would need to be recycled and purified for reuse. Communication and transportation systems would also be essential for the underground civilization to function. Advanced robotics and artificial intelligence could be utilized for mining, excavation, and transportation tasks. Beneficial for us. It could be beneficial for humans to live underground on Mars. There are several advantages to building underground habitats on the Red Planet. Firstly, living underground provides a level of protection from the harsh surface environment on Mars. The thin atmosphere and lack of a magnetic field mean that the surface is bombarded with high levels of radiation and extreme temperature fluctuations. Underground habitats would offer better protection against these hazards. Secondly, underground habitats would provide natural insulation against extreme temperature fluctuations on the surface. The temperature on Mars can vary by over 100 degrees Celsius between day and night, making it challenging to maintain a habitable environment. Living underground would offer a more stable temperature and a more comfortable living space. Thirdly, underground habitats would provide better protection against the planet's dust storms. Mars is known for its frequent and intense dust storms, which can last for months and severely hamper surface operations. Living underground would provide a haven from these storms. Finally, building underground would allow for easier access to underground water reserves. Scientists have discovered evidence of underground water on Mars, which would be a critical resource for sustaining life on the planet. Overall, living underground on Mars offers several advantages and could be a crucial factor in establishing a permanent human presence on the Red Planet. We should have to undergo tests. For decades, Elon Musk, CEO of Tesla and SpaceX, had been insisting that humanity's best shot at long-term survival was to eventually become a multiplanetary species. He cited elevated levels of carbon pooling in the Earth's atmosphere, extreme droughts, and the loss of biodiversity as precursors to a looming catastrophe. He began development on a program called Starship in 2016, which was intended to ferry cargo and, eventually, 100 passengers between the Earth, Moon, and Mars. By 2021, NASA contracted SpaceX to develop a modified Starship vehicle for its Artemis program. Musk focused on building the core infrastructure that would eventually be required to sustain life, whether on Earth or the Moon, Mars, or even beyond. But Musk realized he could not build an off-planet living environment on his own. Ever the showman, and with his fortune approaching $1 trillion, Musk announced an audacious contest called the Colony Prize. He'd award $1 billion to any team that could build and operate an underground, airtight colony of 100 people for 2 years. In other words, the ultimate Mars simulation. 123. Musk knew that for humans to thrive off-planet, regenerative systems would need to be developed at a scale never before achieved. The International Space Station once housed as many as 13 astronauts on board, but typically only 6 or 7 lived in the ISS at once. Colonists also needed to grapple with long periods of confinement. The typical ISS mission was about 6 months. 5 NASA astronaut Scott Kelly had spent nearly a year in space. Cosmonaut Valery Polyakov held the record for a single mission, spending an impressive 437 days on the Mir station in the 1990s. 6. A better example for understanding a 100-person enclosed society was a submarine. But even here, the longest submerged and unsupported mission topped out at 111 days. 7. Winning the Colony Prize would require keeping the doors sealed tight for more than 700 days. The case for settling in caves on Mars. Modules and construction processes conducted on the Martian surface are highly vulnerable. Moving them underground is a feasible idea. On Mars, caves or lava tubes are the result of past volcanic activity formed by flowing lava, which moves beneath the hardened surface of a lava flow, forming a vault. Because the gravity on Mars is about 38% of that on Earth, Martian lava tunnels can be much larger in comparison to those found on our planet. Some openings discovered near the Pavonis Mons volcano measure about 150 to 180 meters across, which means that the lava tunnel underneath can reach a width of 200 meters. This is more than enough to host a Martian mission, with space for future expansion. Thanks to the nature of their occurrence, lava tunnels have a convenient vaulted form and a relatively flat ground, and offer protection from surface temperatures that vary daily from 20 OC to -70 degrees Celsius. Considering that a permanent Martian colony cannot be successful if it depends entirely on supply from Earth, caves on Mars are also an advantage given that they are the most likely place to find frozen water and are spacious enough to support farming. One supporter of the cave concept is the Fourth Planet Logistic, a company that aims to develop and test a pressurized cave shelter. Having recently obtained permission to undertake experiments at Iceland's Stefnseller lava cave, the company proposes to scan a Martian cave with LiDAR-equipped drones and to produce inflatable modules that exactly fit the surveyed geometry. These units would then be deployed inside the cave. Challenges of weight, light, space, and safety. There are certain challenges to this approach. Finding a way inside the cave entails breaking through the vault at a point where its thickness is insufficient to sustain the weight, causing rock and stone debris to fall and block the entrance. Using machinery to lift and lower loads would require a ramp and a cargo lift, though an initial mission with a minimal crew could get by with a hoist and a ladder. A skylight entrance would need to be secured with a 3D printed dome and an airlock. Directing sunlight into the cave is important for the physical and mental condition of the crew, as well as for farming. In the Marstopia competition, organized by 11 magazine, Shane Powers and Linji Wang proposed the idea of creating a dome and a lift shaft out of 3D printed ice, thus solving 3 problems at once: natural light, vertical transportation, and protection. In conclusion, building an underground civilization on Mars is a challenging but exciting prospect that holds enormous potential for the future of human exploration and colonization.